Hi there, Mr. Holcomb here with another episode of the Math Behind the Modules. This is lesson 5, using the identity. For addition, it's 0. For multiplication, it is 1. And the inverse, flip it and switch it. If I have a fraction, a over b, it's b over a. If I have a positive 1, the inverse is negative 1. Okay, that's identity and inverse. To write equivalent expressions. Okay, opening exercise. In the morning, Harrison checked the temperature outside to find it was minus 12 degrees Fahrenheit. Later in the afternoon, the temperature rose to 12 degrees Fahrenheit, positive this time. Write an expression expressing the temperature change. What was the afternoon temperature? So an expression that represented the temperature change was, we started at negative 12 degrees, and it rose to a positive 12. It says, later in the afternoon, the temperature rose 12 degrees Fahrenheit. It didn't say rose to 12 degrees Fahrenheit. It increased 12 degrees. So I would put plus 12. So be careful how it's worded. If it said rose to 12 degrees Fahrenheit, that would have been our final temperature, and the difference would have been bigger. But here we went from negative 12, it rose 12 degrees, and now it is 0 degrees. And we should throw in an F there for Fahrenheit, because Celsius 0 is different than Fahrenheit 0. Okay, B. Rewrite the subtraction as adding the inverse of the following problems and find the sum. That is where I was talking about inverses up here. Okay, so an inverse of addition is its opposite. In other words, its additive inverse. Its distance from 0 is still the same. We're just going in the other direction on the number line. So we have a positive 2 minus 2. I can rewrite that as 2 plus a negative 2. All they're saying is rewrite this as adding the inverse. So we're adding the inverse. This is 2 minus another positive 2, which is the same as plus a negative 2. And when we do that, we get 0. Now, be really careful here. I saw this on a quiz recently. Minus a negative is not the same as, this is what I saw, plus a negative. That is not the same. If I take away a negative 4 and I add a negative 4, that does not mean the same thing. So whenever we have double negative signs, the negative 4 here stays the same. A minus a negative simply means plus. Okay, they cancel each other out, if you will. If you take away a negative 4, it's the same as adding 4. Think of a deck of cards and you have a hand, and one of the cards is worth minus 4. You take that minus 4 card out of your hand, your total now increased 4 points. Okay? Now this one, and I mentioned in class, the word difference means minus. The word and tells us where to put that minus sign. So the difference of 5 and 5. Okay? And that is same as saying 5 plus its opposite, negative 5, which equals 0. Okay? G minus G. Well, the first G doesn't change. This minus, we're going to change to addition, and we're going to add a negative G, is what minusing a positive G means. It's the same as plus a negative G, and we will get, adding our opposites, 0, because all of these are inverses. Additive inverse gives you the identity. And let me add this. Additive identity. The additive identity is 0. The additive identity is 0. This equals 0. That's the additive identity. Move up here. Look what we got. 0. That's our additive identity. So up here it was saying, a little bit higher, writing equivalent expressions using the additive inverse gives us the identity. Okay. Our part C. What pattern do you notice in parts A and part B? Okay, so what we would say here is clean that up, the sum of a number and its additive inverse is equal to 0. Okay? The sum of a number and its additive inverse is equal to 0. Okay, the sum of a number and its additive inverse is equal to 0. Okay. Add or subtract. 16 plus 0. That's the identity. Whenever we add the identity to something, we get that something back. 16 plus 0 equals 16. 0 minus 7 equals negative 7. Negative 4 plus 0 equals negative 4. And 0 plus d equals d. Okay? So what pattern do we notice in parts I through 1 through 4? The sum of any quantity, so here's what we'd write here, the sum of any quantity and 0 is equal to the value of the quantity. The sum of any quantity and 0, let's see if this recognizes it, is equal to the value this one I might have trouble with. No, I didn't. Very good. I can read my hand scratch. Okay, the sum of any quantity and 0 is equal to the value of the quantity. Okay. E. Your younger sibling runs up to you and excitedly exclaims, "I'm thinking of a number. If I add it to the number 2 10 times, that is 2 plus my number, plus my number, plus my number, and so on, then the answer is 2. What is my number?" You almost immediately answer 0, but are you sure? Can you find a different number other than 0 that has the same property? If not, can you justify that your answer is the only correct answer? Okay. So what they're saying is, if I add, I'm thinking of a number. Okay, some number. If I add it to the number 2 10 times, 2 plus my number 10 times. Okay? And so on, then the answer is 2. Well, if we take what we learned in our last lesson, if I have this one number 10 times, it'd be the same as saying 2 plus 10 times some number equals 2. Okay? So I want to find a number that makes this true. I'm trying to get x by itself. In other words, I want to solve for x. So I want to get rid of this 2 over here because I'm adding 2 to 10 times the number I'm looking for. So if I subtract 2, on this side of the equal sign I get 0 plus 10x, or simply 10x. And if I subtract 2 over here, then I get 10x equals 2 minus 2, which is 0. And this is multiplication. So in order to solve this, I would have to divide by 10, and those would cancel, and that would give me just x on the left. So then what I do to one side, I have to do to the other. So 0 divided by 10 is 0. That is the only number that will make that riddle true. Okay, example 3. Example 1. Write the sum and then write an equivalent expression by collecting like terms and removing the parentheses. Okay, so the first thing you're going to do is we're writing sum, and the word and tells us where to put the sum symbol, which is plus. So I'm going to rewrite this first as 2x plus, and in parentheses, negative 2x plus 3. Okay? So the first thing I'm going to do is move my parentheses, and that's called the associative property. So I'm going to rewrite all of my terms just exactly as I see them, but now I'm going to move my parentheses. So I'm going to move my parentheses around my like terms, which are right here. Okay? And whenever we have a plus and negative, we always write another parenthesis there. So it would be 2x plus a negative 2x in parentheses, all in parentheses, plus 3. Okay? And then GEMDAS or PEMDAS says do the grouping first. That's why I say GEMDAS now. And 2x plus a negative 2x is 0 plus 3. And 0 plus 3 is definitely 3. So we have the associative property, the additive inverse. So I'm going to write this. Associative (0 plus 3) is the additive identity. Or additive inverse, I'm sorry. We got the identity from adding inverses, additive inverse. Okay, 2x and a negative 2x added are adding inverses. And then adding 0 to something is the additive identity. Okay? Additive identity property of 0, if you will. Okay. Alright, and the second one. 2x minus 7 and, so 2x minus 7 and the opposite of 2x. The opposite of 2x is negative 2x. Okay? So I'm going to rearrange these. So I'm going to take this 2x minus 7, and I'm going to move this 2x over here, so it's going to be plus a negative 2x here. I'm going to move the minus 7 over to here, or plus a negative 7 over to here. Okay? So 2x plus a negative 2x is 0, plus a negative 7, and then when I add anything to 0, I get that anything. So it's the same properties again, associative property, then additive inverse, and additive identity. Okay, so the associative property was here, going from here to here, moving the parentheses. The additive inverse was adding 2x and negative 2x and getting 0. And the additive identity was adding 0 to negative 7 and getting negative 7. Okay, getting the idea here? Okay, one more. The opposite of, here's my and, that's where the plus sign goes. The opposite of 5x minus 1 and 5x. Okay? Okay, so I'm going to change this to a negative 1. I'm just going to throw a negative 1 in there to explain this. Okay, and that is taking the opposite is equivalent to multiplying by negative 1. Okay, so taking opposite is the same as multiplying by negative 1. Okay? Okay, didn't recognize that, so I'll leave it. I can't read my writing. Taking opposite is the same as multiplying by negative 1. Okay? The next thing I'm going to do is distribute. Let me change colors. I'm going to distribute this negative 1. Negative 1 times 5x is negative 5x. Negative 1 times a negative 1. Negative times a negative is positive. 1 times 1 is 1. And then add 5x. Okay, that's the distributive property. Okay, distributive property. Okay, the next thing we're going to do is rearrange this so I have negative 5x plus 5x plus 1. So this 5x moved over here, this one moved over here. When I rearrange stuff, that is the commutative property. Commutative property of addition. Okay, and moving right along, if I add these, negative 5x plus 5x is 0 plus 1. Okay, let me just move that up a little, we're running out of room. 0 plus 1, well, that's right here. That's the additive inverse. So just to save time, I added inverses, negative 5x plus 5x, and got our identity 0. Okay, and then finally, 0 plus 1 is 1. And that is the additive identity. Okay, the additive identity is adding 0, the additive identity, to any number gives you that number back. Okay? So now exercise 1 says, with a partner, take turns alternating. This out of the way. Take turns alternating roles as writer and speaker. The speaker verbalizes how to rewrite the sum and properties that justify each step, as the writer writes what is being spoken without any input. At the end of each problem, discuss in pairs the resulting equivalent expressions. Write the sum, and then write an equivalent expression by collecting like terms and removing parentheses wherever possible. Okay, so I'm going to pause the video, take some time to do this, and then come back and see if you've done it correctly. Okay, so here we go. Here's the word and, that's where the plus sign goes. So I'm going to write this as negative 4 plus 4b plus 4. Then I'm going to move my 4's together. So I'm going to put negative 4 plus 4, and then put the 4b off to the end. So I just move this over here and this over here. That is the commutative property of addition. Then I am going to do this step here, and I'm going to add opposites and get 0. Negative 4 plus 4 is 0. That's the additive inverse property. Okay, additive inverse. That gives me 0. And then 0 plus 4b is simply 4b, and that's the additive identity. Okay, B. The word and tells us where to put the plus sign. Because we're talking about sum, the word and tells you where to put that sum symbol. So it's going to be 3x plus 1 minus 3x. First thing I'm going to do is get the like terms next to each other. 3x plus a negative 3x plus 1. That's the commutative property of addition. I'm then going to do this portion here. 3x plus a negative 3x is 0. That's the additive inverse. Add inverses gets you the identity. Okay, this is my identity. And then take the identity plus 1, gives me that number back. That is the additive identity of 0. Okay? Alright, C. The opposite of 4x and, there's my and. Opposite means if this is positive, make it negative. If it was negative, make it positive. The opposite of a positive 4x is negative 4x. The sum of that and negative 5 plus 4x. I'm going to move the 4x over next to the negative 4x because they are like terms. So negative 4x plus 4x plus a negative 5. 4x and a negative 4x when added, since they're opposites, they're inverses. Additive inverse property gets me 0 plus a negative 5. And the additive identity, this is my identity. If I add the identity to negative 5, it gives me back what I started with. So the identity 0 plus negative 5 is negative 5. That's the additive identity. Okay. Opposite of a negative is positive, so I'm going to write 10t. The word and tells me where to put my plus sign. T minus 10t. I'm going to change that to plus a negative 10t. I'm now going to move the 10t's together. So I'm going to have 10t plus a negative 10t plus t. So now I see that I have opposites here. 10t plus a negative 10t is 0. There's my identity. Plus t is going to give me t. E. The opposite of negative 7 minus 4b. So to say the opposite of that, I'd put a minus sign out in front. Negative 7 minus 4b and negative 4. Okay? So I can change this to a minus 1, and I distribute. A negative times a negative is positive. 1 times 7 is 7. A negative times a negative is positive. 1 times 4v is 4v. That's a multiplicative identity. Okay? And then I'm going to have plus a negative 4v. I'm going to do this portion first because I see opposites, so that's inverses of each other. So it's going to be 7 plus 0. There's my identity. And 7 plus 0 is 7. So that's the additive identity property of 0. Okay? Okay, example 2. 3/4 times 4/3. Okay, these are inverses. Okay, when we multiply, an inverse is its reciprocal. So at the beginning of the lesson, I wrote A over B times B over A equals 1. I don't know if I wrote B equals 1, but it does. Because if I rearrange this, if I switch my numerators around or my denominators, if I move this over here and this over here, if I will, because multiplication is commutative, so on the top I have A times B, and on the bottom I have B times A, but I can rewrite it as A times B. A divided by A is 1, because anything divided by itself is 1, and B divided by B is 1. So I have 1 times 1 or 1. Okay? So, or you could look at it this way. 3 times 4 is 12. 4 times 3 is 12. And 12 divided by 12 is 1. I'm just trying to explain it in many different ways. A lot of students have trouble with this when they have a whole number times a fraction. Make that whole number a fraction by putting it over 1. 4 times 1 is 4. 1 times 4 is 4. 4 divided by 4 is 1. Same here, if I did that. 1 times 9 is 9. 9 times 1 is 9. 9 divided by 9 is 1. Make this over 1. A negative times a negative is positive. 1 times 3 is 3. A negative times a negative is positive. 3 times 1 is 3. 3 divided by 3 is 1. Okay? You seeing a pattern here now? Another way I can look at this is this 6 will cancel with that 6, leaving 1. 5 can cancel with that 5, leaving 1. And a negative times a negative is positive, and we get 1. Write the product, and then write the expression in standard form. Standard form, meaning all terms are combined that are like. By removing parentheses and combining like terms, justify each step. The multiplicative inverse of 1/5 and, so we're writing the product. Product means to multiply. The word and tells us where to put that product. The multiplicative inverse of 1/5 is 5/1, or simply 5. So the multiplicative inverse of this, so multiplying the multiplicative inverse of 1/5 and times 2x, I'm going to put that over 1, minus 1/5. Okay, this might look a little confusing to you at first, but don't let it scare you. 5/1 is simply 5, so I'm just going to ignore all of that, and I'm going to distribute. 5 times 2x is 10x, or 10x over 1 means the same thing. 5 times a negative 1/5, positive times a negative is minus, or negative. 5, which is 5/1, times its inverse is 1. So my answer is 10x minus 1. They are not like terms, so that is standard form. Okay? The multiplicative inverse of 2. So I'm going to take the multiplicative inverse of 2, which is 1/2. There's my and. That's where my multiplication symbol goes. 2x plus 4. So I'm going to distribute. 1/2 times 2 is 1x. 1/2 times 4, positive times a positive is positive. 1/2 of 4 is 2, and we don't need the 1 in front, so it's simply x plus 2. They are not like terms, so that is in standard form. Okay, the multiplicative inverse of 1/3x plus 5 is 3x plus 5/1. And is where I put my multiplication symbol, 1/3. So we're multiplying the inverse of this, which is this, times 1/3. So multiply the numerator times the numerator. So 3x plus 5 times 1 is 3x plus 5. That's a multiplicative identity. Divided by 1 times 3, which is 3. Okay, now, since this is 2 terms, and this is 1 term in the denominator, I can split those up. Okay? So I can show this another way after, but what I can do now is say, okay, 3x plus 5 over 3 is the same as saying 3x over 3 plus 5 over 3. I can take the denominator and put it under each term of my numerator. That's what that means. So I can rewrite it like this. And then I can see that 3's cancel because 3 over 3 is 1, and I get my final answer to be x plus 5 thirds. And that is my standard form. Okay? Very common mistake. So just keep in mind this is not what you do. Sometimes students will look at this and say, oh, there's a 3 in the numerator, there's a 3 in the denominator, and cancel them and say the answer is x plus 5. Okay? That is totally wrong, absolutely untrue. Do not do it. Okay? Do not cancel a 3 from one term when you're not reducing this term. It's not mathematically possible. So I'm going to get that off the screen altogether because it is so wrong. Your answer is x plus 5 thirds. Okay. Number 2. Write the product and then write the expression in standard form. So here's the word product. Okay. And there's the word and. Product means to multiply, so I'm going to put a multiplication symbol where I see the word and. The reciprocal of 3. That's the same as inverse, 1/3. And I'm going to multiply it by negative 6y minus 3 x. So I'm going to distribute. positive times a negative is negative. 1/3 of 6 is 2. Or 6 divided by 3, if you will. Y. I'm going to distribute. Positive divided by times a negative is negative. 3 times 1/3, or 3 divided by 3, is 1, and then I get x. These terms are not like terms. I am done. This is my standard form. Okay? Now, one thing I didn't do yet, it says to justify each step. Okay? This is the distributive property. Alright? And this is multiplicative inverse. And it's also the multiplicative identity. So I multiplied by the inverse here, but I multiplied 1/3 by 3 and got 1, so that's also the multiplicative identity. Okay? Alright, the multiplicative inverse of 4. 1/4. And times 4h minus 20. You have to put that in parentheses because you're dividing everything by 4, or multiplying everything by 1/4. So 1/4, this is the distributive property. I'm not going to write this every time. First we distribute. 1/4 times 4 is 1h. 1/4 times a negative 20 is a negative 5. So the multiplicative inverse was multiplying by 1/4, and I got the multiplicative identity when I multiplied it 1/4 by 4. Because the inverse of 4 and 4 are multiplicative inverses and give us the identity 1. It is in standard form. The answer is h minus 1. Okay, multiplicative inverse of negative 1/6, and don't forget that inverse, the sign does not change, so the inverse of negative 1/6 is negative 6. Multiplicative inverse, not additive, so the sign does not change. And 2 minus 1/6j. Multiply, distribute, a negative times a positive, and say this while you're doing this. You should not make mistakes with your sign. First thing I ever look at is sign. Negative times a positive, negative. 6 times 2, 12. And I just methodically move left to right, and it gets very easy. Okay, now I'm going to multiply the negative 6 times the second term. Negative times a negative is positive. 6 times its reciprocal or inverse is the identity 1. I don't need to write it because 1 times j is simply j. So once we start doing this, we can cut corners a little bit by not showing all the steps with the 1 in front of the j and then getting rid of it. Okay? But if you're not comfortable doing that, then put a 1j here and rewrite your answer as negative 12 plus j from your last step. So if you want to show your 1 here, and that's the multiplicative identity here. Okay? Alright, that's the end of lesson 5. Now go do your problems.